So we are going to continue the next part of discussion, NLM only, some basic problems. So now the question here is, there is a block on a surface. Now the force is applied on this like this, with an angle theta. So there is a friction here, mu. Static friction is mu s, kinetic friction is mu k, and the mass is m. Now find say this is F, minimum force to move the block. So this is what the question, this is the third question in a sequence, third question or fourth question as of now. Instead of numbering, I can give an example. It's an example. So answer. So as we discussed earlier, every time we take the directions properly, and this is a mass m. So this is the force we should resolve into components, so along the directions. So this is in this direction f cos theta, in the vertical direction it becomes f sin theta. Now f free body diagram, horizontally the force is f cos theta, and the downward direction the force is f sin theta. Are there another forces, contact forces? Yes, there is a normal also, and there is a friction in the backward direction. What kind of friction? Static friction or kinetic friction? So minimum force, when there is a minimum force that is mentioned or words to move, there is static friction, that is mu s into n, static friction. Now we are solving it. Words to move is acceleration in x direction becomes 0, acceleration in y direction also becomes 0. So now there is one more force. What is the other force? Gravitational force. Gravitational force is acting in which direction? Downward direction. It is equal to mg. Actually it will be at the center, but I drew in a little sideway. So now we are writing sigma fx is equal to max. This side, right side is positive, left side is negative. We are resolving into component. F cos theta is positive. Sigma fx is equal to 0, because m into ax ax is equal to 0, minus mu s into n is equal to 0. So f cos theta is equal to mu s into n. And next, vertical force, sigma fy is equal to 0. So n is in the upward direction, so n is positive. Mg is in a downward direction, negative. F sin theta is in downward direction, negative. If we write the equation, n is equal to, or else upward force is equal to downward force, n is equal to mg plus f sin theta. So f cos theta is equal to mu s into, say this is equation 1, equation 2, equation 2 in equation 1, into mg plus f sin theta. So the f is equal to cos theta minus mu s into sin theta is equal to mu s mg. So the finally f is equal to mu s mg over cos theta minus mu s sin theta. This is one of the simplest example. Okay, so hope you understood this part. Next we are going to multiple blocks. Next example. So let's take, there are multiple blocks, similar blocks. So as of now, let's do for the two bodies. Now I am applying the force F here. So there is a friction. So first let's do without friction, and then we'll do with friction. So this is the case without friction. Okay, each of mass m1, m2, and the questions they ask, simple question can be, what is the acceleration? Easy question. And the second question, that is, what is the reactive force between the blocks? Reactive force between the blocks. So to solve this, So sometimes we can assume more than one block as a single system. If you draw these two bodies are there, m1 and m2 are there, so I can assume these two as a single body because there is no friction here. Even if there is friction also we can assume, but I will teach you how to assume that. So m1 m2 as a single block, I am getting the total mass of the block as m1 plus m2. So this is the force. The acceleration is equal to, there is no friction, there is no opposing force, so F is equal to ma, F is equal to m1 plus m2 multiplied with A is equal to F over m1 plus m2. This is the easiest question. And the next question comes to what is the reactive force between the blocks. Reactive force between the blocks. So listen carefully. Now in this case we are drawing free body diagram of individual block m1 m2. So I'll copy this question once. So this is the question. So if we see carefully, in between the blocks, so this is the contact surface. On this m1 there will be opposing force from m2. This in this direction it is opposing. Now how m2 is moving? Because of some push from m1. So the normal reaction is acting on the both directions. So if you draw the free body diagram, the force F is in this direction on m1. So what the reactive force does between the blocks, you try to oppose the moment of F1. So it is in this direction, R I am saying. And there is a friction, there is no friction, and there is mg, m1g, and there is a normal n1. Now let's go to the m2 part. How this is acting? A reactive force is pushing the m2. So this R, and there is no friction to oppose it. So there is m2g in the downward direction. The force is in the upward direction, normal force n2. Now reaction is equal to, we know the acceleration, ax is equal to how much? F over m1 plus m2. So sigma fx is equal to max. If we solve this, sigma fx means we took the directions right side as positive. So F minus R is equal to m, what is the mass? m1 into acceleration is equal to F over m1 plus m2. So let's write R is equal to F minus m1 F by m1 plus m2. It is equal to m2 F over m1 plus m2 is the reactive force. So if we solve this way, we will get a reactive force, and we can solve from here also. Second, this is the first free body diagram, second free body diagram. From second also we can get. So we will get directly from the second. R is equal to m2 into acceleration. R is equal to m2 as it is m2, as is A is equal to m1 plus m2. So both the cases, so answer is same, which is easy to consider from the last block. It becomes easy to solve. Okay, thank you.